Today we're going to talk about more techniques for finding limits. Yesterday we saw how to use the graph with our zoom in and trace. We also saw the way we could use our table and make small changes in the delta table for the x values. Today we're going to talk about direct substitution, which works for functions that are continuous near x, and using right and left limits. So we're going to take the limit as x approaches -2 of the function x to the third minus 6x plus 5. Okay, this is a polynomial function, and when we studied polynomial functions, we talked about the fact that they are continuous everywhere. So for this particular function, which is continuous everywhere, it's definitely continuous near -2. So we're going to be able to do direct substitution to find the limit. So -2 cubed minus 6 times -2 plus 5. So this is -8 plus 12 plus 5. So the limit is 9. Here's a cube root function, and the cube root is also continuous everywhere. So we are going to be able to do direct substitution. So the cube root of 10 plus 3 times -3. So the cube root of 10 minus 9, which would be the cube root of 1, which is 1. So the limit is 1. The limit as x approaches 5 of 6 over x plus 2. Now, a rational function is not continuous everywhere. It has vertical asymptotes sometimes. This particular one does have a vertical asymptote at -2. So the look of the graph is going to be, there's a vertical asymptote at -2 and a horizontal asymptote at 0, and it's probably going to look something like this. But we're not asking for the limit as x approaches -2, which doesn't exist there as a limit. As we approach from each side, we are not nearing the same value. At 5, way over here, this function is continuous, so we can use direct substitution to find the limit as x approaches 5. We do 6 over 5 plus 2, so 6/7 would be the limit. The limit as x approaches 1/4. Now we know tangent is not continuous. It's got that kind of rocket kick line look with lots of vertical asymptotes. But for this particular tangent wave, 1/4 is not a place where one of those vertical asymptotes is. So we will be on a continuous portion of the tangent. So tangent at pi times 1/4 over 2, which would be the tangent at pi over 4 over 2. Here's where our memorized trig comes in. The tangent at pi over 4 is 1 over 2, so the limit is 1/2. Now we're going to talk about left and right side limits. So the limit as x approaches 3 of the function, the piecewise function, that's defined by x squared minus 2 if x is less than 3, and 2x plus 4 if x is greater than or equal to 3. Each of the individual pieces is continuous. This is a parabola. It's continuous all along its domain, and this is a line. But they've asked us for the limit at 3, which is actually the crossover here. So if we look at the piecewise graph, let's see, x squared minus 2, so down to 1, 2, 3. If I plug in 3, this should be at 7, 2, 4, 6, 7. And a parabola has nice symmetry. So the shape of the parabola, stopping right here. And then the line starting at 3, so, oops, I drew this badly. Okay, so now our line at 3 would be a 10. 1, 2, 4, 6, 8, 10. So right here. Slope of 2. So our line is going this way. Okay, so as we approach 3 from the left, as we approach 3 from the left, the graph is approaching 7. As we approach 3 from the right, that would be this part of the graph is approaching 10. So it's approaching 7 from the left. It's approaching 10 from the right. So we would say that the limit does not exist because it is two different values. Let's contrast that with, we'll keep the x squared minus 2 for x less than 2, but replace it with the absolute value of x minus 10, which would be a shift to the right of 10. 2, 4, 6, 8, 10. Absolute value has that nice V shape. So as we're approaching 3 from the left, the graph is approaching 7. As we're approaching 3 from the right, the graph is approaching 7. So even though this is two separate pieces, they do come together. So we would say the limit is 7. Here's some other little interesting tidbits. If the limit as x approaches some constant, c, some number, of f of x is 10, and the limit as x approaches c of some function g of x is 2, then we can actually answer questions without seeing either graph. So the limit as x approaches c of 3 times f of x is going to be 3 times 10, 30. The limit as x approaches c of f of x plus g of x is going to be 10 plus 2, 12. And the limit as x approaches c of f of x divided by g of x would be 10 divided by 2, or 5. Okay, so see what you can do with this.